These real experiments nearly caused disasters, broke all rules, and some ended in silence. You won't believe what really happened. In the world of science, there are moments where curiosity overrides caution. This is one of those moments. Karl Patterson Schmidt was one of the most respected herpetologists in the United States. He spent his life studying snakes, reptiles, and venom. But what happened to him in 1957 is the kind of story that feels more like a scene from a thriller than real life. It started with a delivery. The Lincoln Park Zoo in Chicago had received a snake and couldn't identify it. Naturally, they called Schmidt. He took one look at it and realized it was a boomslang, a rare and highly venomous African tree snake. At the time, very few cases of human envenomation by boomslangs had been recorded, and many believed the species wasn't particularly dangerous to humans. Schmidt didn't agree, but he was about to test that theory in the most unexpected way. While handling the snake, it bit him on the thumb. He could have gone to the hospital right away. Instead, he did something few would ever consider. He turned his own body into a science experiment. Over the next 24 hours, he calmly wrote down everything he felt, every symptom, every reaction: nausea, chills, bleeding from his gums. He wanted to document the effects of the venom with full precision. Here's what makes this so shocking. Schmidt didn't believe the bite would kill him. That's why he kept going with his notes, even as the symptoms worsened. He even went to work the next morning, but within a day of the bite, his body shut down. The venom had destroyed his blood's ability to clot. It was internal bleeding, quiet and unstoppable. What makes this story unforgettable isn't just the risk he took. It's that he was one of the few scientists in history to record the process of his own death, step by step, in his own handwriting. Today, his notes are still studied in medical circles. And the boomslang? It became famous worldwide, now known as one of the most dangerous snakes on Earth. This story sounds like something out of a historical drama, but it happened in real life and it changed the course of medicine. Jesse Lazear wasn't just any doctor. He was part of a research team sent to Cuba to investigate yellow fever, a brutal disease that had wiped out entire communities and terrified anyone living in tropical regions. At the time, nobody knew exactly how yellow fever spread. Some thought it came from dirty water. Others blamed direct contact. But a theory was growing that mosquitoes were the true carriers. The only problem? It hadn't been proven. So how do you prove something that dangerous? For Jesse Lazear, the answer was personal. He bred infected mosquitoes in the lab and exposed himself to their bites. No safety suit, no backup plan. He wanted proof, and he got it, but at a steep cost. Within days, he developed high fever, chills, and liver failure, classic yellow fever symptoms. He had confirmed the mosquito theory beyond doubt. What's important to understand is that this wasn't a reckless move. Lazear knew the risks, but he believed the discovery could save thousands of lives. And he was right. Thanks to his experiment, yellow fever was finally traced to its source, and public health officials around the world began to fight it with mosquito control instead of isolation wards. Today, there's a memorial at Johns Hopkins University honoring Lazear's contribution. He never lived to see how much good came from his sacrifice, but because of him, yellow fever could be fought with strategy, not fear. The gamble he took changed medicine forever. This next case isn't about a scientist taking a risk. It's about a man who never agreed to be part of an experiment and didn't even know it was happening. Albert Stevens was a house painter from California who walked into a hospital in the 1940s for treatment of what doctors thought might be stomach cancer. What happened next reads like something from a Cold War conspiracy. Stevens became one of the first human test subjects in a classified government radiation study. Without his knowledge, he was injected with a large dose of plutonium, a radioactive substance used in nuclear bombs, all to see how it would move through the human body. Here's the twist. Stevens didn't have cancer at all. He would go on to live for another 2 decades, unaware that his body was carrying some of the highest levels of internal radiation ever recorded in a human being. He was monitored closely, but no one told him the truth. This experiment was part of a secret program where scientists were racing to understand radiation exposure during the early days of nuclear weapon development. The data they gathered from Stevens and others was used to build protective standards and safety protocols that still exist today. But the ethical questions never went away. Years later, when the documents were declassified, the truth came out. Stevens had unknowingly helped shape nuclear medicine and radiation science, but at a cost he never agreed to. In the world of dangerous experiments, this one stands out for its secrecy. Not every risk is taken by choice. Sometimes history is shaped by those who didn't even know they were part of it. This experiment wasn't about testing a cure, it was about watching what happens when a deadly disease is left untreated for decades. From 1932 to 1972 in Tuskegee, Alabama, hundreds of men were enrolled in what they were told was a government medical study. They believed they were being treated for bad blood, a vague term that covered everything from fatigue to anemia. But the real purpose was never explained to them. In reality, the men had syphilis, and the scientists wanted to observe how the disease progressed without medical intervention. Even after penicillin became the standard cure, they still weren't treated. Doctors tracked their health, took notes, and let the disease run its course just to gather data. What made this so dangerous wasn't just the illness itself, it was the violation of trust. These men thought they were getting help. They weren't. Over time, the study became a symbol of how science can go too far when people aren't treated with honesty and respect. Eventually, the story broke publicly and the backlash was massive. The experiment was shut down. Years later, a formal apology was issued, and changes were made to ensure that no medical study could ever be run in such secrecy again. The Tuskegee study didn't use high-tech equipment or experimental chemicals. Its danger came from what it didn't do and the silence it maintained. It taught the world that ethics mattered just as much as results. For years, rumors swirled about secret experiments carried out by government agencies in the name of national security. Project MKUltra wasn't just a rumor. It was real and exposed to repetitive sounds, bright lights, or sudden silence for days. The boundaries between science and cruelty blurred fast. Eventually, the project was shut down. But by then, dozens of locations had been involved, and thousands of documents existed, many of which were destroyed. The ones that survived revealed a shocking picture of how far some were willing to go in the pursuit of control. In popular culture, MKUltra has become a reference point in everything from Stranger Things to The X-Files. But behind the fiction, there's a deeper truth. The most dangerous experiments aren't always done in a lab coat. Sometimes they happen behind locked doors in plain sight, with no one ever knowing until years later. In the spring of 1980, scientists knew something was happening beneath Mount St Helens. Earthquakes, gas releases, and small eruptions had been shaking the region for weeks, but no one knew exactly when the big one would hit. That's where David Johnston came in, a young, dedicated volcanologist with the U.S. Geological Survey. Johnston was stationed just 6 miles from the summit at an outpost called Coldwater II. His job was to monitor the volcano and report any sudden activity. On May 18th at 8:32 a.m., his final radio transmission came through. Vancouver. Vancouver! This is it! Seconds later, the side of the mountain exploded. A massive lateral blast, one of the most violent eruptions in U.S. history, flattened everything in a 230 square mile zone. Johnston's post was directly in its path. The force of the explosion was so intense it stripped entire forests and launched ash 15 miles into the sky. Johnston was never found. What makes his story unforgettable is the bravery behind it. He knew the risks, but he stayed because the data he was collecting could help save lives in future eruptions. And it did. Thanks to scientists like Johnston, volcano monitoring advanced rapidly after the disaster. Today, the ridge where he stood bears his name, Johnston Ridge. It serves as both a memorial and a reminder of how science sometimes demands more than just knowledge. Sometimes it demands presence, courage, and the willingness to face nature's full force head-on. At the heart of atomic research in the 1940s inside a quiet lab at Los Alamos, something terrifying unfolded a moment that revealed just how dangerous working with nuclear materials could be. Physicist Louis Slotin had become known as an expert at handling plutonium cores, even before the first atomic bombs were tested. But his confidence would lead to one of the most infamous lab accidents in history. Slotin was demonstrating a criticality experiment involving a plutonium core later known as the Demon Core. The idea was simple in theory. Place 2 beryllium hemispheres around the core and slowly bring them together to measure how close they could get before the core became critical. Slotin had done this many times. Too many. Instead of using safe remote tools, he used a flathead screwdriver to separate the 2 halves, balancing it with his hand, hovering just above a nuclear reaction. Then the screwdriver slipped. For less than a second, the core went supercritical. A flash of blue light filled the room, the signature of a critical reaction. Everyone nearby felt a wave of heat. Slotin instantly pulled the hemispheres apart, stopping the reaction and saving the others. But it was too late for him. He had absorbed a massive burst of radiation. Over the next several days, he developed the classic symptoms of radiation exposure, but at the time, no treatment existed. Slotin died 9 days later. His last act was heroic, preventing a greater disaster, but his method became a textbook case of what never to do with unstable materials. His story is now part of nuclear science history. Labs across the world updated safety protocols in response, and the term the Demon Core stuck a chilling reminder of how thin the line is between knowledge and catastrophe. In the summer of 1971, an ordinary hallway in Stanford University's psychology building was transformed into something that no one expected: a simulated prison. It was supposed to be a simple study. College students were divided into two groups, guards and prisoners, and asked to play their roles for 2 weeks. What happened next would become one of the most disturbing experiments in behavioral science. Within just 24 hours, the guards began to assert control. They made the prisoners follow strange orders, do repetitive tasks, and obey humiliating rules. Some guards invented punishments on their own. And the prisoners? Many of them fell into depression, confusion, or open rebellion. What was meant to be a controlled simulation quickly spiraled into something that felt real. The experiment didn't even make it to the halfway point. After just 6 days, it was shut down. The emotional toll on the participants was too intense, and the ethical concerns were impossible to ignore. Why is this considered so dangerous? Because it revealed how easily ordinary people in the right environment could slip into roles of power and submission. The experiment showed that systems and structure could influence behavior far more than anyone expected. The Stanford prison experiment has since become one of the most referenced studies in psychology. It's been the subject of films, documentaries, and countless debates. And its lesson sticks. It doesn't take much to blur the line between a role and reality. Sometimes the scariest transformations don't come from what we do, but from what we believe we're allowed to do. In the early 20th century, Joseph Barcroft was determined to understand how extreme altitude affects the human body. But rather than use someone else as a test subject, he put himself inside the chamber. Literally. Barcroft, a British physiologist, constructed a sealed glass chamber that could simulate high-altitude conditions by removing oxygen from the air. Then he climbed inside and stayed there for days. No backup team was standing by with emergency oxygen. He was alone, breathing thinner and thinner air, measuring every change in his pulse, breathing rate, and mental clarity. At one point, oxygen levels in the chamber dropped to the equivalent of being 17,000 feet above sea level. His lips turned blue. His speech slowed, but he kept taking notes. It was one of the first times a scientist had subjected himself to a study this physically demanding. What makes this so remarkable isn't just the danger, it's the control. Barcroft knew exactly what was happening to his body, even as his organs were being pushed to their limits. He wanted to understand how pilots, soldiers, and climbers might survive in low-oxygen environments. His findings helped pave the way for safer flight and altitude medicine. Today, his chamber still stands in scientific archives as a reminder of what personal commitment to research can look like. Barcroft didn't just test theories, he lived them breath by breath. When the world's first atomic bomb was tested in the New Mexico desert, the scientists behind the Manhattan Project gathered to watch a moment that could change everything or end everything. As the countdown to the Trinity Test approached, a few theoretical physicists had raised a disturbing question. What if the explosion was strong enough to ignite the nitrogen in the atmosphere? Could it cause a chain reaction that burns the sky and destroys the planet? It sounds like science fiction, but this was a real concern. Equations had been written, risk calculations debated. The answer wasn't 100% certain, but they ran the test anyway. On July 16th, the explosion lit up the desert with a light brighter than the sun. The ground shook, a fireball rose into the sky, and the mushroom cloud formed. Earth didn't ignite, but for a brief moment, humanity stood right on the edge of the unknown. The Trinity Test marked the beginning of the nuclear age. The technology developed from it would go on to reshape the world. But so would the fear that something so powerful could escape control. This experiment stands out not just because of its scale, but because of the risk that even the scientists weren't sure of. It asked a chilling question. What happens when we cross into realms we don't fully understand and press the button anyway? In 1962, at the Oklahoma City Zoo, a group of researchers decided to test a strange theory that hallucinogenic substances might trigger a hormonal state called must in male elephants, a condition that can cause them to become highly aggressive. The elephant chosen was named Tusco. He was a large, healthy bull, well known at the zoo. Without warning, the researchers injected him with a massive dose of a powerful compound. The result was immediate and tragic. Within minutes, Tusco collapsed. His muscles spasmed. His breathing slowed. The researchers tried to revive him, but within 2 hours, he was gone. It was a test with no real precedent, and the outcome shocked even the scientists involved. The dosage turned out to be far too high, not even comparable to human levels. And the idea that the test would somehow mimic natural biological behavior turned out to be deeply flawed. The incident quickly became one of the most criticized animal experiments in scientific history. Though it was intended to explore chemical effects on behavior, it ended up proving just how little we sometimes understand about dosage, scale, and interspecies reactions. Tusco's case became a turning point. It fueled a wave of discussion about ethics in animal research and led to stricter review processes for similar studies in the future. Sometimes the most dangerous experiments aren't the ones that go wrong by accident, but the ones that never should have been run in the first place. When the Large Hadron Collider, or the LHC, was first turned on, it wasn't just the biggest scientific machine ever built, it was also one of the most feared. Nestled deep underground along the border of Switzerland and France, the LHC was designed to smash particles together at nearly the speed of light, recreating conditions close to those just after the Big Bang. For scientists, it was the ultimate tool to unlock the secrets of the universe. For some people, it sounded like the start of a disaster movie. The internet lit up with theories. Could these collisions create a black hole? Would Earth be swallowed? Even some scientists considered the possibility briefly. The idea was based on physics that suggested a microscopic black hole might be produced under the right conditions. But calculations showed that if such a thing were created, it would instantly evaporate too tiny and unstable to last. Still, the panic was real. Lawsuits were filed to stop the collider. Public debates exploded, and when the LHC powered on in 2008, all eyes were on it. What happened? It ran smoothly. No rips in space-time, no black holes, just data, incredible amounts of it that helped confirm the existence of the Higgs boson and reshape our understanding of mass itself. Today, the LHC is still running, upgraded and more powerful than ever. But that initial fear revealed something important. When science goes big, public reaction can be just as explosive as the machines themselves. The collider didn't destroy the world, it just opened a door a little wider into what the universe is made of. This wasn't an experiment in the traditional sense, but what happened in Bhopal, India, became one of the most tragic lessons in industrial safety, or lack of it. On a December night, in the heart of a city home to nearly 1 million people, a pesticide plant owned by Union Carbide began to leak toxic gas into the air. The gas? Methyl isocyanate, highly reactive, highly dangerous. A water reaction inside one of the plant's tanks caused a runaway chemical reaction. Pressure built, and just after midnight, a valve gave way. A cloud of poisonous gas rolled out over sleeping neighborhoods. Within hours, thousands of people had been affected. Panic spread. Hospitals were overwhelmed. Entire families were caught in a wave of confusion and choking fumes. In the days that followed, the death toll rose into the thousands. Over 500,000 people were exposed, with long-term health effects that lingered for decades. What made this so deadly wasn't just the gas, it was the failure of safety systems. Warnings had been ignored, equipment hadn't been maintained. When things started to go wrong, there was no backup. The Bhopal disaster is now taught around the world in engineering, chemistry, and ethics courses. It's a harsh reminder that the most dangerous experiments aren't always done on purpose. Sometimes, the danger comes from shortcuts, cost-cutting, and the belief that nothing will go wrong. After Bhopal, global standards for chemical plants changed dramatically. The world learned the price of ignoring risks. It's a case where science, business, and responsibility collided with devastating consequences. This one has become the stuff of online legend, creepy photos, dark rooms, and stories of people who went mad from lack of sleep. But behind the viral myth lies a shadow of something very real. In the Soviet Union, especially during the mid-20th century, researchers pushed the limits of physical and psychological endurance, often in secret labs where few rules applied. The idea was simple but chilling. What happens if people are kept awake for long periods using forced stimulation? Not just staying up late total sleep prevention. In early experiments, subjects were isolated in soundproof rooms, exposed to constant light, and monitored for signs of mental breakdown. Food and water were provided. Sleep was not. Over time, volunteers began to unravel. Concentration dropped. Mood swings became violent. Some became paranoid, convinced they were being watched or tested in more sinister ways. After several days, hallucinations began, auditory first, then visual. In some cases, participants forgot who they were. One test reportedly had to be stopped when a subject became unresponsive, simply staring into space, unable to form words. These weren't stories made to scare. They were part of broader studies into how the human body handles stress, isolation, and sleep deprivation conditions soldiers and cosmonauts might face. And while the most extreme internet tales may be fictional, the foundation is anything but. What made these tests dangerous wasn't just the loss of sleep, it was the slow, methodical erosion of the mind. Today, we know that prolonged insomnia can lead to hallucinations, organ failure, and deep cognitive damage. Yet back then, researchers kept going chasing a threshold they didn't fully understand. In the end, the Russian sleep experiments revealed something terrifying. Take away a person's sleep and you don't just tire their body, you change who they are. It's one of the clearest examples of how science, unchecked, can drift from exploration into something far more unsettling. That's about it. What kind of experiment would you like to do? Write in the comments, and don't forget to check out our other videos.